Hello everybody, my name is Sam, and today I'll be walking you guys through a data analytics fraud detection project. And I wanted to set a constraint for myself. So I'll only be using Excel and SQL. Now we normally use Python for machine learning and sklearn for train split tests to detect fraud. However, with this project, I just want to use Excel and SQL. So the data set that I'll be using, the name of it is Fraud Detection in E-commerce Datasets. It was uploaded by Kevin Vagan, and it was updated 12 days ago from today, and today's March 15th, so March 3rd. And you guys could find this on Kaggle. Now, the exact data set I'll be using is data set number 2. This is the one with about 150,000 rows and 10 columns. So let's open up SQL and let's run our first query to view the data set. So this is how it looks. Now, don't mind the Benford's Law column. This is something that I added personally. Now we have the user ID, the sign up time, purchase value, and this is monetary. So this is how much money they spent. Their device ID, source, browser, sex, age, IP address, and class. Now 1 means fraudulent for class and 0 means it is a legitimate transaction. So the first thing I wanted to do was run the first digit law test. So this is another name for it is Benford's Law. And essentially we run this test to see if the data set has been manipulated or if there's some obvious manipulations or questions that may arise from the overall data integrity. So the first thing I did was added that column, Benford's Law, and I updated that column and I set that column to the left of purchase value by 1. So purchase value is right over here. And the first value is going to be what is going to be used for Benford's Law. So the next thing I did was found the percentage distribution for each number. So there's 1, 2, 19, 3, 4, 5, 6, 7, 8, 9. So all the way up to 9. Now I want to show you guys how the normal Benford's Law, how the chart would look versus our chart. So this right here is how it should look for data that has not been manipulated. So we see 1 is greater than 2, 2 is greater than 3, so on and so forth. And we see this downwards moving trend to signify data integrity. Now I'll show you guys how ours looks. So essentially what I did with this is transferred it onto Excel and visualized it, right? Now, when we look at our plot, we can see that the data roughly follows Benford's Law. And it's important that we remember that this is just one piece of the puzzle when understanding data integrity. So this is not a definite test for data integrity, right? So there's always other analytical models and ways of understanding data integrity. So just from a first glance on a high level perspective, we can see that it is following Benford's Law, but we do have some anomalies such as 9 and 1. So these two values may be manipulated. However, on a high level, it is following Benford's Law. So that's awesome. So now let's go back onto SQL and let's go down to the data analytics portion. Okay, so let's place that. So now with the data analytics portion, what I wanted to do is understand how each variable from each column has an impact on the class. So with Python, essentially what we're doing with this would be a correlation map, right? So we would see the correlation between class and other variables in the data set. And I want to show you guys how that would look on Python for another data set. So you can see right here, this is a correlation map. Now let me just click it right there. So essentially they're looking at how class is correlated with all of the said 28 variables. Now, the higher the number, the higher the correlation, the lower the number, the lower the correlation. So you just be looking for darker blue variables. So we see V2, we see V4, if I'm not wrong, V11, so on and so forth, right? So this would be important when starting your train test split with sklearn to see what variables have an impact on the class. However, since we're doing it with SQL, it is going to be a little more harder, and I wouldn't say harder, but a little more, it would take a little bit more time. However, we're essentially doing the same thing. And since we have less variables, it won't be as much time as you may think. So the first thing I wanted to do was look at sign up time by the month and see the fraudulent distribution. So the way we visualize this is we would write this query. So we would extract the month from the purchase time as month, count. You could use sum here, but I just use count. If you use sum, you can do else 0, but since I'm using count, I have to do else no. And we'll look at the amount of fraudulent and legit transactions, and we'll group it by the month. So we can run it, and we see this right here. Now we would transfer this onto Excel and visualize it and have a better understanding. However, with the Excel portion and the data visualization we'll do at the end, we'll just run through all of these first, all of these queries. So we have this. So this is by the purchase time. So the time of purchase by the month. Now we could also do this by the day, and I think that would also be good. So let's also add that. I didn't think of the day. I just thought of the month just for these purposes. Now we also have it by the day, right? And we'll remember this. So I'll make sure to add this onto Excel so you guys could actually see me do it on Excel and understand how I visualized it. Now we also have the sign up time, and we also did this by the month. So we essentially did the same query. Now we're also doing the day difference. So the difference in days between the sign up time and the purchase time. And we grouped it by the difference in days, right? So we're subtracting the sign up time by the purchase time and finding that difference with the interval of, with the date. So the days. So we see right here, these are same days. So 0 means the person signed up today and made a transaction today as well. So there's no distance between the day, the sign up time, and the purchase time in days. Then 1 means there's a difference by 1 from the sign up time and the sign up day, and so on and so forth. Now here we also wrote down the purchase value, and I wanted to find out the minimum and the maximum purchase value so that I can kind of group them and create a purchase value group. So we seen the minimum was 9, the maximum was 154. I wanted to group it by intervals of 9, and that's what I did right here. And so we're going to group it by that, and also create also have a column for the amount of fraudulent transactions for each purchase value group. So we execute that. So we see 21 and 30, legitimate, fraudulent, so on and so forth. Right? Now, this might seem like it doesn't make sense right now, but that's only because we're looking at the queries. But once we start visualizing, it'll make a lot more sense. Now, I also wanted to do it by the date. So our minimum date was 18, maximum date was 76. So I created groups, essentially did the same thing as the previous query, and we could run this. And yeah, so that one isn't supposed to be there. This will be this. There we go. So now we have the age group, the amount of fraudulent transactions, the amount of legitimate transactions for each age group. Awesome. The next one I wanted to look at was the source. So we essentially did it with the source. And this time I did fraudulent transactions percentage, and we got this right here. So 10% came from direct, 8% came from SEO, 9% came from ads. Now, we could also round this so that we get this. However, the only reason I didn't round and multiply by 100 is because I was transferring it onto Excel, and I did that part, the rounding and changing it to a percent value with Excel, so it saved me some time. So we have this right here. Next, we're going to look at it by the sex, and we have legitimate and fraudulent for each sex. So this is awesome. Now, also, what we could do even right here, we don't even need to write that. We could just write this same part of the equation and have this. It'll be a little less, it'll be less redundant, and it's kind of summarized a little bit more. So now let's go on to Excel, and let's also scroll up, because I know I said I was going to add this one also to Excel. So let's just copy this. And before we look at this, let's go here and let's add that variable. Okay. So this is, I believe it was the month, if I'm not wrong. Purchase time in days, yeah. Day. And this is legit transactions, fraudulent. And we could merge and all right, now we could also add this into here just for, yeah, we also have some space right here, I think. Oh, I was wrong. All right, we'll just add it right here. And I'll also make this into a pivot table. No, not pivot table, I'll format it, sorry. And just set these up to the same. I can't remember what shade of blue I used. I believe it was this one, yeah. Okay, great. And I think this is formatted right. Somewhat right. Okay. And we'll also add this graph as well. So we'll do insert, and we'll do a graph for this. So we would pick a graph. Now, the graph that you pick is really dependent on the data set. So I think for me, I would like to use this, a line chart, maybe something like this. Yeah, something like that. Yeah, so let's see, insert. Yeah, something like this. So I'm gonna grab this down here. And we'll format this. Can't remember the exact color format I used. I believe it was this one, yep. And we'll remove these lines. And let's remove the border. And the name of this was purchase value. Great. So just okay, awesome. And that's essentially how I added the graphs for each for each table that I created, right? So I hope I wanted to kind of show my thought process as well with creating those graphs. So I hope that did it for you guys. Okay, so now let's actually review the tables first. So these are all tables that I've created using our SQL queries. Now we could have done this using pivot tables. However, as I mentioned, your Excel will crash because the data set is simply way too large. So we had the Benford's law test, and we had spoke about it, and that's right there. Now we also have well, let me see what the date difference. So this is the date difference for fraudulent transactions, and it's grouped day by the day. Right now, we could also, some people also like conditional formatting. So you could also use conditional formatting just depending on the data set. But since we're using data visualization, we are just going to use our graph. So when we scroll down, we could see the day difference, right? So the dark green is fraudulent transactions, and the light green is legitimate transactions. Now we see fraudulent transactions are extremely high between 0 and 1. Now as soon as we get to 1, the fraudulent transactions and legitimate transactions lines intersect, and legitimate transactions, there's more legitimate transactions compared to fraudulent transactions. So that's very interesting to note. The next one we're going to look at is purchase time and fraudulent transactions. So this is the month of the purchase time, and these are the number of legitimate and fraudulent transactions. So when we come down here, we can see that the purchase time of 1, so the month 1, which is January, we see a large amount of fraudulent transactions, right? Now we could also add the data labels if you want to have a look, but I believe the data labels are kind of useless since it's not pivot tables. So we could see a large amount on month 1. We see a large amount also, second largest I would say, on month 7, month 5, and we see them kind of dropping down as we go, right? So that's very interesting. Now the next chart is sign up time and fraudulent transactions. So the sign up time, as I mentioned, we categorized it by the month. So signing up on January, February, March, April, May, June, July, August. These are the number of legitimate and fraudulent transactions. We come down here, and we can see right here, this is very interesting. So this is legitimate transactions, this is fraudulent. So we see a large amount of fraudulent transactions from month 1 all the way to month 2. However, we also see a large drop of legitimate transactions from month 7 all the way to month 8, right? So that's a big drop. That's about, I would say, yeah, that's about a 50% drop within just 1 month. And we also see a 50% drop in fraudulent transactions from month 1 to month 2. So that's very interesting. Okay, awesome. Now the next one is age group. So with age group, there really isn't a noticeable pattern. We see legitimate transactions are dropping as the number of people and the count of customers. Age groups are also declining, so that is a positive correlation. However, we do see a kind of stunt right here where you see the fraudulent transaction line kind of briefly pause up here for the number 36 to 40. So customers 36 to 40, we do see a little stunt in fraudulent transactions. However, for the rest, we do see a drop. And we also see that for 31 to 35 as well. The next graph is purchase value group and fraudulent transactions. So this is in dollars. So, right, so we're grouping it. So there's 21. So from $21 to $30, 31 to 40, so on and so forth. And we can come down here and see that distribution. So we see fraudulent transactions all the way, the largest amount of fraudulent transactions from 21 all the way to about 60, right? So we see a large amount of fraudulent transactions right there. but these are in line with the distribution of legitimate transactions. So there is a natural distribution, right? So that's not a telltale sign or an indicator of fraudulent transactions. Whereas when we see here, there is not a natural distribution in legitimate transactions and fraudulent transactions. We see a large amount of fraudulent transactions on one, right? Whereas also here, there is not a natural distribution, even right over here. Now, the other graph we added was the source in fraudulent transactions. So we see 10% come from a direct source. So people clicking on the website from a direct source. So you could see 10% right here, 8% right over here, and 9% right over here. So direct has the largest percentage of fraudulent transactions. Now this is the one we just added, purchase date by the day and fraudulent transactions. So we do see from day 1 all the way to 12, we see a large amount of fraudulent transactions right over here. And we see a drop in legitimate transactions from day 30 all the way to 31, while fraudulent transactions are also on a downward trend. However, it is still in the same area of fraudulent transactions for the past 15 days. So this is all very interesting, especially the data visualizations. Now, what you're faced with when creating a profile for fraudulent transactions is finding the visualization that you could add to the final query to group these fraudulent transactions with. So the ones we will be paying attention to are the sign up time and the date difference for fraudulent transactions. So we see a huge amount of fraudulent transactions up here. So we're going to be accounting that in our final query. Then we also are looking at, let's go down here, the sign up time. So let's find that sign up time graph. Purchase sign up time right over here. So we see a large amount of fraudulent transactions over here. So from sign up time month 1 all the way to 2. And then we're also looking at the source. So the source direct, 10% of them come from direct. So we're also going to include that in our final query. So let's look at how we built this final query. So we have the month of the sign up time as month, the source, the count in legitimate transactions, count in fraudulent transactions, and the fraudulent transactions percentage. And for the constraints, we're going to do date diff where it's less than 1. And that's for this chart right here, right? And then we're going to do source direct. That's pertaining to this chart right here. And then the last one is sign up month less than 2. And that's pertaining to this month right here. So this query was created on a high level view. Now we can drill down on each variable and each category and create that final formula and make it a tad bit or a bit better with Excel and SQL. However, for this project, this is kind of done on a high level. So that's why we're only including those 3 variables, right? And we're looking at anomalies. As I mentioned, this is a natural distribution. This one right here, it's not as significant of a jump. So we're not paying attention to these other charts, right? We're paying attention to the ones with very large, a very intense amount of distribution. So let's run this query. And we have 99% of these transactions with these clauses result in a fraudulent transaction. So we have 1,656 fraudulent transactions and 9 legitimate transactions. So this can be done to flag these transactions. So when the transactions with the date difference being 0, so same day purchases, and they're direct, and also the sign up month is January, we could flag that transaction as fraudulent and investigate it more. Now we could also add on to this and include this chart right here. And I believe this chart was purchase time and fraudulent transactions. So we could do that. And let's find that. So purchase time and fraudulent transactions. And we're only going to include month 1. So let's actually do this together. Oh, my apologies, guys. We already did include it. So that's all. That's fine. So we have our final query, and we've been able to detect, and now we're able to flag these transactions that have these clauses, and hopefully decrease the number of fraudulent transactions within that said year by 1,656. And this is 10% of the overall fraudulent transactions. So let me show you what I mean. So we're going to do this from fraud where class equals 1. Right? So 1,656. And let's run. And this is 1,400. So 14,151. So let's grab our calculator. Right? And then what we'll do is that's 1,400. And this one is, let's take a look one last time. That's 11% of the fraudulent transactions. So we'll be able to successfully flag 11% of, we can round it up, 12% of these fraudulent transactions. So that is absolutely amazing. And now we could also look at how much money we could save the company. We could have saved that company for this said year. So we could also do that by doing select sum purchase value. I believe that was the name of it. Let me just double check. Fraud purchase value. Yeah, purchase value from fraud where this so let's just separate this. Yep. So this is $62,000, right? So that's how much money we could have saved the company. And we could also look at the sum of the entire number of fraudulent transactions. So $523,000 that were fraudulent. We could have saved the company $62,000 of that $500,000 of fraudulent transactions. So I hope you guys enjoyed this walkthrough. To be honest, this wasn't really a complicated project. It is quite easy. So if you guys enjoyed it, make sure to let me know. And yeah, I'll try to post some more project walkthroughs if they're fun for you guys to watch, and if they're somewhat educational. Now, I don't do YouTube full time. I'm just doing this so that I can help someone who is getting into data analytics kind of get their feet wet and understand the fundamentals of data analytics or fraud analytics or so on and so forth. So thank you for watching, and I hope you guys have a wonderful day. Bye-bye.